Hello. Today we are creating borax crystals out of a supersaturated borax solution. For our experiment, we will need borax. We use the 20 mule team brand, some water, pots to heat the solution in, a coloring agent such as food coloring, or in our case we are using watercolor paints, a string, and some pencils to tie the string to. To begin, we boil the water in the pots. Once the water is boiling, we add borax and stir it to dissolve it. We continue adding borax until no more will dissolve. At this point, we have a supersaturated borax solution. We add some of the watercolor palette to each solution in order to give our crystals a nice color. Next, we take the yarn and knot it to form a base for the crystal to begin to grow. We tie one end to the pencil and use this to suspend the yarn within the borax solution. We take the pot with the red solution and place it in an ice bath. The other one is placed off to the side to cool slowly. The red solution formed crystals faster as the temperature change occurred quicker due to the ice bath. The crystals were checked again the next morning. Here are a picture of the two finished crystals. The formation of the borax crystals is evidence of a phase transformation. Different phases are defined as different homogeneous regions in a system with distinct and uniform physical and chemical characteristics. At the beginning of the experiment, we start with one phase, the borax solution. As the solution cools, the borax solution will transform into the water phase and the borax phase, thus creating our crystals. The phase transformation is not instantaneous, but rather occurs in stages. First, small particles of the new phase, the pure borax, must form. This step is known as nucleation. There are two types of nucleation. Homogeneous nucleation is when particles form uniformly throughout the mixture. For homogeneous nucleation to occur, the temperature must be lowered below the equilibrium solidification temperature, Tm. This is known as supercooling. Homogeneous nucleation is difficult to create, and our experiment demonstrates heterogeneous nucleation. In heterogeneous nucleation, the nuclei form on pre-existing surfaces. The activation energy, delta G star, and the surface free energy, gamma, are reduced for the solution. This allows heterogeneous nucleation to form easier. In our experiment, the string provides a surface for the nuclei to form. In order for the growth stage to begin, the nuclei must grow large enough. The nuclei must exceed the critical radius, or star. Once this has happened, the growth can occur, and the crystals will increase in size. The crystals from the ice bath are smaller than those allowed to cool at room temperature. The ice bath crystals formed faster and did not have a chance to form larger crystals. These crystals also contain more impurities due to the accelerated formation. The blue crystals form slower and contain larger crystals and less impurities. You can clearly see the grain boundaries of each individual crystal in the two larger crystals. The red crystals are more brittle and crumble easily because they contain a greater number of impurities. The blue crystals are much sturdier and do not crumble as easily. As you can see, this experiment has explained the phase transformations as well as the different stages of nucleation and growth. We hope you enjoyed this video or maybe even inspired to create your own borax crystals.